Gemini.
Hi, guys. I hope you've had a great conference. I'm really excited to be speaking to you today. My clicker is not clicking, so I'm going to use this. OK, so hello, world. I'm Christina. By day, I'm a software engineer. I work at Vistaprint in the greater Boston area. I have a bunch of my colleagues here. By night, I am a total nerd. I love hanging out at meetups, going to hackathons, and checking out the latest and greatest in technology. Here's an obligatory picture of me wearing a dorky AR glasses that I'm sure in 5 years people will laugh at, if not now. But the thing is, this picture was taken at a hackathon, and a lot of my experiences with augmented reality and virtual reality actually come from hackathons. I still remember the very first hackathon that I went to that was a VR hack. And during that time was the first time I tried the Vive headset. Before that hackathon, I didn't even know what a Vive headset was. I didn't know what a cardboard was. I didn't know what the difference between the two were. Going to this and experiencing virtual reality for the first time was awe-inspiring. It's something that you really have to experience in order to understand. Since then, I've gone to a ton of other hackathons with a bunch of my friends. The one at the top is the Discover AR hackathon, and there we invented a way in order to do gesture-based authentication for virtual reality spaces. Hololens was another hackathon with using the Hololens, and for that we did things like sonar for the blind and subtitles for people. So the versatility of virtual reality is boundless. You can do anything that you put your mind to. And it's really, really exciting living in the present. The technology that we have today is what we have been dreaming about for years. Does anyone remember this scene from Star Wars? Which doesn't have sound. Anyway, the idea is that when this scene came up, it was the very first representation of augmented reality in the cinema. This is when Princess Leia asks for help from Obi-Wan Kenobi. And so this is interesting, right? Because this was decades ago, and we are still not quite there with the technology. But we have made a lot of progress. So I have a short quiz for you guys. Can you guess? This is called a stereoscopic photo. Can you guess when the stereoscopic photo was first made? 1920, 1940, or 1960? OK, raise your hand if you think it's 1920. 1940? 1960? Wow, you guys are all right on. OK, how about this one? So this device was made in 1950. Can you guess what it was called? The SenseBox, Virtual Sphere, or Sensorama? SenseBox? Virtual Sphere? Sensorama? Nice. So if you think about it, we've been thinking about virtual reality and what it means to be inside of a different world for a long time. The Sensorama was supposed to be not just vision, like the stereoscopic photograph, but it also incorporated other senses, things like sound, also feeling. So for example, have you ever gone to those 4D movies where they'll like show something scary on the screen and spritz water on you to make it feel as if it's attacking? So stuff like that. The idea of virtual reality and augmented reality is that it augments all of our senses, not just vision or sound. OK, what about this device? It's starting to look a little bit more like a cardboard. Is it the Vision Box, Telesphere Mask, or reality glasses? Vision Box, Telesphere Mask, reality glasses? This one's Telesphere Mask. So as the years progressed, these devices became smaller and smaller, and we started attaching it to our vision. OK, one more. This is called the Vpl Data Suit. Can you guys guess when it was invented? 1980, 1990, or 2000? 1980, 1990, 2000? Cool. It was 1989, so 1980s. So the VPL data suit, the whole idea was that this was rigged with motors and vibrators so that as you walked around in this virtual world, you could feel different objects there. Now, it looks really doofy, and it feels kind of silly to do something like that. But the thing is, stuff like this exists today. In fact, one of my one of my colleagues from university started a company recently called Hard Light VR. And they do this full-on bodysuit that you put on, and as you walk around in the virtual world, it'll vibrate across your back so that you can feel as if you're hitting against a wall and stuff like that. So these dreams are really becoming realities. And if you think about it, there's so many different devices on the market today. This is the Vive. Has anyone here tried the Vive before? Okay, a bunch of you guys. The Vive is a virtual reality device, but it also has a camera on the front, so you can do augmented reality, so you can see your surroundings. It comes with 2 controllers, and the way that this one works is that you're tethered to like a desktop computer. So although you can move around in maybe like a 3-meter square box, you can't really move past that. This one's called the Oculus Rift. It's very similar. It has controllers, and it's also tethered to a desktop. Then we get into devices that allow you to move around freely because all of the processing is on board the device. So this one is the Google Daydream. And with this, what they did was all of the processing for it is on your phone, similar to the Google Cardboard. And lastly, there's things like the Hololens. This one, again, has all of the processing on the device. In fact, it has a Windows 10 machine running on the device so that you can walk around. The HoloLens is different from these other devices because it's augmented reality. And what that means is instead of just being able to see the screen in front of you, you can see the surroundings and see holograms overlaid on top of it. So that's pretty cool. And have you guys seen this in the news? Anyone? So this is a new augmented reality device called the Magic Leap. And whether or not we'll be walking around with devices like these strapped to our heads, I'd like you to imagine a future of augmented reality. So in this video, this is a video called Hyperreality. It's a simulation of what a shopping experience might be if you have augmented reality everywhere. And so here, there's a little pet that's kind of like a shopping helper that tells you what you forget. But as you look around, you see that there are ads shown on different parts of the store. You can see that it recognized that those are coconuts or pineapples, and based on that, it's able to say, hey, you forgot this item in your grocery cart. Or it's able to add additional information about any item you pick up. Now, what would a world like this look like if it crashed? So here's an example of the system rebooting. And here you can see that once the system is off, this is kind of the imagination that they had, is you have a bunch of markers in order to detect where to place this augmentation on top of. In order to do augmented reality like this, we need markers in the real world that are able to tell us where the device goes on top of. So it's funny that we use this as imagination, but this is 2 years ago. Alibaba already offers a VR shopping experience. You can put on a cardboard headset, go into the store, and pick out products that you want to buy. You can look at it, and you can check out right from that virtual store. So this isn't really the future. It's already the present. There are other devices, there are other applications of virtual and augmented reality too. Discover VR applied it for an educational purpose. And what they did was, if you wanted to, for example, teach kids about sharks, you can't take them underwater, but you can give them a headset to take a look at different wildlife. This idea of using virtual reality for education is really interesting because it gives you a new way of processing information. One of the hackathons that I judged last year, the MIT Reality Virtually Hackathon, one of the teams had a really interesting idea. Say you have a ton of MRI scans that are flat 2D images. What if we pile them up and stack them right next to each other so that you can get a 3D vision of the brain? It's a whole new way of processing data that used to be static, because now you can look inside the human body or look inside the brain and analyze things in a way that you never could before. And then there's more fun applications. Anyone here still play Pokemon Go? Pokemon, oh wow, 2 hands went up, maybe 3. Pokemon Go, maybe a year ago, was like all the rage. And why was it so popular? Although it was a very simple idea, there wasn't any interaction between the Pokemon and and its background. It made it contextual. It made it feel as if the Pokemon was actually there. And this is really easy to do, right? You could do this in a web browser super simply. Just use a video feed and then overlay a div on top of it. Augmented reality. Augmented reality does not have to be complicated. Another example of a useful product that you might think of is Wayfair. Wayfair came out with this augmented reality application that would let you visualize furniture before you bought it. Because they're an online shopping retailer, they want you to be able to feel confident in the furniture that you buy and how it would look in your space before you make the purchase. Now, this was originally written using the Google's Tango-enabled devices, but I believe that they've now moved on to AirCore. So there's a lot of different kinds of devices that allow you to do really interesting things these days. Virtual and augmented reality are about to revolutionize how we live and experience the world around us. If you think about it, these examples that I showed you might seem kind of silly, but so did the first few years of the internet. It kind of feels like the space that we're in right now with virtual and augmented reality is like 1990s. We're just figuring out what it should look like, what it should feel like, and it's a really exciting time to be in. And because of this, I think it's really important to talk about who has access to these devices and how we can make it more available to everyone around the world. Democratizing AR means that, 1, everyone has access to an AR-enabled device, and 2, anyone can build augmented reality experiences. Now, if you look at all of those devices that I showed you before, none of those were web-based, right? We had the Vive, we had the Hololens, we had the Oculus. But the thing is, if you look at how many of these devices sold and compare it to the Google Cardboard, for instance, you'll see that the Google Cardboard vastly outsold all of the other devices combined. What is this telling us? People that are trying out virtual and augmented reality for the very first time are doing so on low-end devices, things like the Google Cardboard, or on their mobile phones. And if you think about it, that makes sense. Our mobile phones have become so powerful over the last few years. It's possible to do augmented reality applications with them. So if you think about it, everyone already has access to an AR device. It's in their back pockets, our phones. And the second one is anyone can build an AR experience. If we make it easy to put together an augmented reality experience, just as it is to build a website, then anyone can start building these things by themselves. So, as web developers, I believe that we can shape the future of virtual and augmented reality by building applications for the mobile web. There are already a lot of APIs that enable us to do this, and so today I'm going to talk to you guys about one way that we can get there. So first, let's talk about the present state of web VR and AR. So first, when you think about web VR, there are a lot of different libraries out there. The most basic of which is WebGL. WebGL is if you want to write like pure vector math in order to develop your virtual reality applications. 3JS is a JavaScript library that was built on top of WebGL. And what it does is it exposes higher level APIs so you can do things like create cameras or place objects without really having to worry about like all of the vertex math. There are two more libraries that I'm really excited about right now. One is A-Frame, which you might have heard about before, and the other is React 360. A-Frame allows you to create virtual reality applications using a component-based architecture, like HTML components. So in order to, for example, create a box, you just have HTML tags and a box. It's very simple. You should definitely check it out. React 360 is another interesting one. Especially at JSConf, I feel like a lot of us are really into React. And the reason is because it helps us manage complex application state. So if you have a virtual reality application that has many different components that need to talk to each other and need to be able to say, hey, like this button was clicked, so turn this view on, React 360 is a really interesting choice. React 360 offers something that has a model that's slightly different from A-Frame. So it has this notion of panels and models. A panel is basically something in 3D space that's flat. So think of something like a paper or a poster on the wall. A model is something that's three-dimensional. Think of like a model of a sofa. We'll come back to this later. Now let's talk about web AR. So web AR is still kind of in its infancy. There are three kind of big libraries that people tend to use when working with web AR. Aw.js is one of them, JS Aruco, and lastly, AR.js. The thing is, all of these libraries, so Aruco and Aw.js are built on top of the Aruco. So Aruco is basically a library that was written in C that allows you to detect certain types of markers and figure out what the pose is of those markers so that you can put items on top of it. I'll explain that in a second. AR.js uses AR Toolkit on the underside. So those are like the two competing frameworks right now. AR.js is pretty awesome. Like, I think of all of the libraries that I've used so far, AR.js seems to be the one that's furthest along. You can use AR.js with A-frame. So for example, if you want to create augmented reality in your A-frame application, there's this really easy component that you can use in order to add augmented reality to your A-frame application in less than 10 lines of HTML. So if this is something that works for you, then definitely check it out. Now looking at the slide, you're thinking, OK, Christina, you're just telling me to go home and check out AR.js. But the thing is, I've used this before, and I ran into some problems, especially because the markers aren't very customizable. These are the markers that all of those libraries that I talked to you guys about before use. So they use the Aruco markers or the hero markers. AR.js uses the hero marker, and you can customize what goes in the middle of it, but you can't customize the borders. So you still have these really thick black borders if you want to use these markers. And while it's fine for some applications, if you want to put it on like a poster, or if you want to put it on something that is designed, it can be a little bit frustrating to have to deal with these limitations. So that's kind of where we're at right now with WebVR and AR. There's a lot going on, and it's constantly evolving. Next, I want to talk to you about QR.AR.js and how you can use it. So what is QR.AR.js? When I was working on a project a while ago at a hackathon, I noticed that these markers look just like QR codes, and yet they're not. So the idea was, could we use QR codes instead? Now, QR codes don't have to look ugly. Snapchat uses basically a QR code in order to share contact information. The one right below that is from Twitter. So Twitter also uses QR codes. And you can customize QR codes to your heart's extent, pretty much. You can change the color. You can change the corner eyelets and the dots that go inside of it. This means that if you wanted to add a QR code to your design and make it look make it designed to fit with the rest of your so make it fit with the rest of it, you can definitely do it. The other thing is, because QR codes are actually a code that is standardized across multiple different platforms, many phones already have QR code scanners. For example, iPhones have a QR code scanner in the Chrome browser, so you can just point to a QR code and scan it and go to the website directly. So this is kind of how standards proliferate, right? I wanted to come up with a new way of combining QR codes with the existing AR libraries. So introducing QR.AR.js. QR.AR.js is a way for you to add augmented reality to your applications that uses QR codes as markers. There are two different types of models that you can add to your applications. One is a 3D model, and second is a 2D plane. And this is partially inspired by React 360's notion of planes and models. And the idea is, if you want to create a 3D object, then you probably need a higher level of computation. But if you're just transforming a 2D plane, then you can probably get away with doing a little less. That's my demo. It works. So that's a great transition. So instead of talking about it, I figured it would be a good idea to just show you what I mean. So we'll see if this works, because my presentation is on a different slide. OK, so here we are. OK. So earlier, you might have noticed that a bunch of these cards were on your table. You can go ahead and try scan the QR code. Disclaimer, I haven't tested this on all mobile devices, just my own, and it was still a little janky, so definitely try it out, but you can also try it out on your laptop. It might be smoother. You can just go to QR.AR.js.com. So I'm going to go ahead and open up the first demo, which is this guy. So what this is doing right now is it used the get user media in order to pull the video feed from the browser. And then once it had that, it added it to the screen using a canvas. You see some glitching. It's not perfect yet. But what this is doing is now it's overlaying my R2D2 on top of this. Remember that example that we looked at earlier where R2D2 was projecting a hologram? We're going to try and go ahead and recreate that using QRAR.js. So the first step is we need to create a 3D model. In order to create a 3D model, I used a software called Blender. So basically, what I did was I used Blender in order to create this model. It's kind of cute if you look at it when it's stable. I basically just took a sphere and a cylinder, joined them together. Then I used something called a texture paint in order to paint on top of it. You can go ahead and download an actual model off of a lot of different websites. There are a lot of sites that offer free models that you can use. But in essence, there's two main pieces to the model. There's the object file and the material file. So the object file basically says, this is what the 3D object is. And the object file is dictated by a set of vertices. So for example, in the case of R2, you had points alongside everywhere on the sphere. You notice that it wasn't perfectly round. This is in order to optimize for performance. The fewer vertices there are, the less vector math you have to do. The second piece of the puzzle is the material file. And what the material file says is, given this image, how do you map it on top of the object? Let's take a look at those right now. So if I go ahead and open up my console, should be able to show you this guy. So this is my beautiful painting of R2D2. So if you look at, all of this code is on GitHub, by the way. I'll show you that in a second. But this is the texture map that it's using. And so the material file says, given this image, how do you wrap it around this model object? OK, so what does the code look like for this? I'm using the QRAR 3D library. And can you guys see this in the back? Can you give me a thumbs up? OK, cool. So what I'm doing here is I'm using the QRAR library. First, I need to use 3JS. The library takes in a 3JS object. So you can pass in whatever you want. You could create multiple different objects and group them together if that's what you want to transpose on this plane. But it's unopinionated about that. So you need a dependency on 3, the 3 object loader, and the 3 material loader. Lastly, over here, I'm importing the QRAR library itself. So it's on unpackaged, so you don't have to use NPM if you're kind of just in the browser. But if you are in NPM, you can just NPM install that. Once we have that, this is all the code it takes in order to write this. So first, we're getting 3. This is just a selector. The important code is over here. First, we're creating a material loader and an object loader. Once we have that, we're saying load all of the materials from this asset path. Load the R2D2 MTL file, which is the material file. And once these are preloaded, set it on the object. Then load the R2D2 object file. And once we have that, we will have a 3JS object, which we can pass into QRAR3D. The only line of code that you really need from the library is this one right here. You just call QRAR.js, QRAR3D, pass in the library 3JS, and then you need to pass in the root element. So this is where it'll go ahead and add this whole overlay. So it'll go ahead and request for user media, then create a canvas and add the video overlay. This is telling it about how big your marker is in the physical world. So in this case, it's about 10 centimeters, so 100 millimeters. You need this because when you transpose a marker in the real world, you need to know how much to rotate it by in the virtual world. So you need the size of the actual physical marker. Next, you pass in the object. And lastly, you pass in a scale of the object. In this case, the object was kind of small when I exported it, so I just bumped it up by 20. And that's pretty much it. Once you have this, QRAR will go in, find the div that's passed in this case, QRAR3D. And if we look at it in the Elements panel, you'll see that it added 2 things. This canvas is the 3JS canvas. So this is the WebGL canvas that it renders the model on top of. And the second thing that it added is this video, so that it streams the video from the webcam feed. And once you have all of this, you can just put this in front of it and rotate it around. And that's pretty much it. So So in a few lines of code, you're able to add a 3D model to your application. It automatically detects the QR code, and it's able to transpose the image on top of it. You don't have to worry about any of that vector math. And all you really need to do is just create the 3D model that you want to pass in and configure it. I want to show you another demo. So this one is using the 2D Transpose method. So if you go to QRAR 2D HTML, this is just a flat image. And once it loads, you'll see that it's transposing this image on top of this object. Let's take a look at what this looks like. So I mentioned earlier that there's the two different types of models. The 3D model where you want to create like a whole 3D object and you want to put it in the scene. And secondly, the 2D plane. So this is like, for example, if you wanted to replicate something like paper or a menu item that you wanted to click around in. Now, one thing that kind of frustrated me when I used React 360 is that it doesn't actually support HTML or regular JSX. You have to write specific components like texts or VR buttons in order to create a panel. So what I did here was using the same principles as the 3D model. It's a little glitchy, so bear with that. But the code is really simple. In order to set this up, we just need one line of code. That's it. QRAR.js, QRAR2D, it takes in three things. One is the root element, similar to the 3D version. The second is the size of the marker, again, same as the previous version. And the last is it takes an HTML element. So you can pass in any HTML element into this. In this case, we're passing in this panel. And all the panel has is this image asset logo. But this could have anything in the world. It could have text, it could have menu, it could have a whole React app or an iframe. And what it does under the hood is it goes in and it uses the same math in order to figure out what the transpose is, and then it uses CSS transforms in order to overlay the HTML element on top of that QR code. What this means is that we don't need like a WebGL canvas, so we're saving a lot of computational power there. It also means that if you already have something that you kind of want to throw together really quickly, then it's easy to do. If you've ever dealt with like trying to add just a simple image in like the 3D world, you know that it's like a huge pain in the butt. This is way easier, right? You just need an HTML element and you can pass in whatever you want to it. And so with this one line of code, you can create a flat panel in this 3D space. That's pretty much all you need. And if you look at what it generates, all it has is this is the panel that we're passing in. Actually, I wonder if this works. I could probably edit it. I haven't tried this. Let's see if that works. So if I add hi on there, you can see that, you can barely see it, but it's at the top of the JS. So like anything that you want in there. So you could imagine some of the possibilities here. If you were to use something like this, then you could create things like an additional menu. Or for example, I'm just making this up, but say you have a business card and you want to have like a add me on LinkedIn button. You could totally do that. It's just a website, right? OK, cool. So with that, I'll go back to my slides. OK, so just to recap, we looked at two different demos. One was the QRAR 3D version. In order to get this to work, all you need to do is first import the library, import the 3JS dependencies, and then you can use it in your code. Over here, the only line of code from the library that you need to use is QRARJS.QRAR3D. You pass in the three library, a root element, the size of the scale, and lastly, the object and the object and the scale of the object. For QR/AR2D, what you can do is you just need to, again, import the library and create an element called panel. Or it doesn't have to be called panel. Just create an HTML element, and then you pass in 3 things. The root, which is where the whole thing gets, the video and everything gets added. The second is the marker size. And lastly, it's the HTML panel that you want to transpose on top of it. The interesting thing here is you can combine the two as well. So let me go back to my demo. So this is the one that you guys were probably seeing earlier. But if you go to index.html, you will see that I've recreated that R2D2 message. Over here, you have this, you have the bot, and you have both the 3D and the 2D overlaid on the same transpose. This is just a simple example, but you could imagine you can do anything with this. If I hit this, it'll play a sound. I think my computer's muted, but you guys kind of heard it earlier. so yeah. OK, now let me go back to my slides one more time. Sorry about that. OK, so you can combine QR/AR 3D and 2D. And if you want to use this, as of an hour ago, or it's on NPM, under QR/AR.js, so feel free to download it, try it out, let me know what you think. It's also on Unpackage and on GitHub. All of the stuff that I did today is also going to be on GitHub, so you can use it as examples if you want to build your application. So that's QR/AR.js and how you can use it with a few lines of code. Lastly, I want to talk to you about the next steps with QR/AR.js and what's in store for augmented reality in the web. So let's talk about how QR/AR.js works. It boils down to these few steps. So first, we need to get the user's media. So this gets the video stream from the user. In order to analyze this, right now I'm putting it on a canvas because there's no way to get image data directly from a stream. So once we have the image data, all that is it's a giant array of all of the pixels. This gets passed into the marker locator. In our case, the marker is a QR code. And what it does is, given an image, it returns the 4 corners of the QR code. Those 4 corners get passed into something called the pose estimator. So it turns out this is actually a very challenging problem. If you have an image of, if you have any image and you have 4 points on that image, on a flat 2D image, figuring out what the 3D transpose was in order to create that is actually a very interesting problem to solve. And especially when those 4 points are coplanar, so they're all on the same plane, you can't 100% be certain what the 3D rotation is. So earlier you saw some glitches. That's because of that. But there are some algorithms out there that can improve that a bit. And lastly, once you get the pose, so the pose is the rotation and the transpose. So for example, like how many degrees it's rotated in each angle and how far along in each X, Y, and Z plane it is moved along. Those get passed into the 2D view render and the 3D view render. And what those do is those then create the 2D view and then the 3D view, depending on whether you want a plane or a model. So before we talk about some improvements, let's quickly recap on the event loop. So the event loop, if you can think of this as the event loop, JavaScript is single-threaded, so it can only ever do one thing at a time. What this means is if you're executing code, it can't render. This is why it's called a loop. So, oh, you can't see my mouse. So the process goes around in the circle. And it has a few different things that it needs to do in order to re-render the site. Style, layout, and paint, just to oversimplify a bit. So every time you render something on the page, it goes through the cycle. Now, what happens if you have to perform a task, say looping through an array of 1,000 pixels? What it does is when it's performing this task, it can't go in and render your scene. So what this means is that your scene will seem kind of janky, and that's where I'm at with the library right now. The other thing is, it can also always the browser can decide whether it performs the task or skips it or performs the render or not. So what you can do in order to alleviate some of this is use things like a web worker. A web worker is a way to add a secondary thread to your JavaScript. Right now, all we've been using is the UI thread, but you can spin up a worker thread. This is similar to service workers if you've heard of that term before. And what it does is it takes your task and does the processing on that thread. I tried to use this for the project, and what I found out was that right now there's a bug where there's a huge security vulnerability with shared memory buffers. And so in order to share memory from one thread to the other, you have to serialize it down to like a string and then deserialize it. And so when dealing with really large images, this ended up being slower. Like the serializing and deserializing ended up being slower than just processing it on the main thread. But I expect that to change in the future. Another thing that you can do to improve this performance is to use something like WebAssembly. If you use something like WebAssembly, then what it does is it makes it faster to process tasks. This is because all of your JavaScript is already compiled, so it doesn't have to interpret it when it's running. Again, I tried to look into WebAssembly, and one of the libraries I looked at was AssemblyScript. All of the code I have right now is written in TypeScript, and AssemblyScript is a library that allows you to take TypeScript and transpile it down to WebAssembly. However, using this, I learned that AssemblyScript isn't exactly TypeScript. It's a subset of it. And so I would have to get rid of a lot of my classes or custom types in order to use it. But that might be another optimization to do in the future. So the two places that we can optimize are with the marker locator and the pose estimator. For the marker locator, I based it off of this library called JSQR, which is a pure JavaScript library that detects the QR code. But you could imagine that if there was a more efficient library that was, say, written in Rust or C, we could use WebAssembly in order to use that faster functionality. The second one is pose estimator. So this is the thing that I explained earlier, that given the 4 corners on a 2D image, it's actually quite complicated to get the 3D transpose of it. And in order to get this to work, I based it off of JS Aruko. Turned out that that library had a few bugs in it already, so that's why some of the stuff that I was seeing was not exactly right. But one optimization in the future would be to maybe like move all of the pose estimator code off to a web worker, because that way it frees up space for your render cycle. And if you guys are interested, this is all on GitHub. It currently has 2 contributors, but if you know anything about WebGL or vector math, feel free to contribute to it, or just check it out. So I really believe that the future of augmented reality for the web is what we make of it. I think that going along, there's a lot of different libraries that have popped up in the past, and that will continue to pop up in order to do AR in the browser. So with that being said, I want to leave you with this question. Why do you love JavaScript? My favorite thing about JavaScript is that I love it because of its reach and its versatility. Writing applications in JavaScript is easy because you don't need to set up a whole development environment. Anyone can do it. It's very easy to write JavaScript in a script tag in an HTML page on the browser. I'm really excited about this prospect because it means that we can allow anyone that's a really beginner to programming to build things like augmented reality. And this is just scratching the surface. There's so many new technologies that are coming to JavaScript and to the web land, especially with things like WebAssembly. So for example, like TensorFlow.js is now a thing, so you can run machine learning in the browser. And I think it'll keep growing. The mobile web is powerful enough to run virtual and augmented reality today, and everyone already has a mobile device. So I invite you to build the future of augmented reality together. Thank you.